Hey everybody, Mr. Briz here. I'm not dead yet. Anyway, so since I can't be in school again for today, instead I'm going to be recording the notes. So what you should be doing is complete the notes on your own. When you are done, please either take a picture and send them to me on Schoology or just turn them in. I will be grading your notes then as an assignment, just to make sure that you are getting your work done and you're not bothering the substitute teacher too much. So first thing, go ahead. I want you to pause the video, answer these two warm-up questions. When you're done, play the video again, and I'll explain how to do that. All right, everybody. So for the first one, what you should have done here, remember that we have a negative exponent and we want that to go back up to 0. So because that's increasing, we need this number to decrease. So we're going to start with the 3.023. Decrease means that we will have to move our decimal point to the left and had to go 4 spaces. So 1, 2, 3, 4. There's our new decimal point. 1, 2, 3. We have to put that many zeros in. So our answer for this first one was going to be 0.0003023. Then for the second one, this time our 8 has to be reduced down to 0. So 5.1 is going to get bigger. So if we start with the 5.1 there, and then we have to go 8 spots to make this number bigger. 1, 2, 3, 4, 5, 6, 7, 8. That's where the decimal point goes. Fill in all of those zeros there. And then we should include some commas as well. There's 1, there's 1. Okay, so your answer for this second problem should have been 510 million. Awesome. So I know it's been a while. If it's been like 2 weeks that we started scientific notation, and we've really only learned 1 or 2 things. So what we're going to do today is we're going to learn how to add and subtract scientific notation. This might have shown up on the MCAs, I'm not sure, but now you will officially know how to do it. So just like what you saw from the warm-up there, the first thing that we have to do, as A from scientific notation is going to increase, we know that N has to decrease. And then the opposite is true for this second line as well. When A decreases, we know then that N has to increase. So now what we're going to do is we're going to take the first number and we want to get the exponents to be the exact same. So you'll notice in this first one that we have a 4, and then in the second one we have a 3. So clearly what we have to do is we have to reduce that 4 to become a 3. And we know then that because that went down, the number in front is going to have to go up. So 4.25 times 10 to the 4th power, if I take that 4.25, since the number had to increase and we're going to be changing only one number for the exponent, we just have to go one place, and we're going to change 4.25 into 42.5. Now the difference here though is we are not getting rid of the full scientific notation, we're just changing it, so we still need to have the times 10, and then it's going to be to the 3rd power. And now you can see that our exponents on 10 match. The reason we are doing this is a necessary step in order to add 2 numbers that are in scientific notation. So the same is going to be true for these here. This time you'll see that we've got -9 and -7. I'm telling you to rewrite the first number to become just like the second number. So we're going to take the -9. In order to get it to be -7, that's increasing. So be careful with negatives. It goes up to -7, which means then that the number in front, 9.328, has to decrease. So if we're trying to figure out now how do we take this number now and change it so that it becomes to the -7 power, our decimal point, we're going to have to create our make our number decrease. It has to go to the left 2 spots. That's going to give us a 0 there. And so our answer is going to be 0.09328 times 10 to the -7th power. As you can see, now our exponents match. We will be able to add or subtract these numbers together now. So what I want you to do now is pause the video. I want you to answer both of these. You are supposed to make the first number have the same exponent as the second number. So that means that your answer for the first one should have an exponent of 6, and your exponent on this second problem here, you want to be changing that to -3. Pause the video, try it. I'll give you the answers in a little bit. All right, now that you've tried this, let's go ahead and figure it out. I'll show you the answers. So, as I was telling you, 8 has to get reduced to become 6, which means that this has to, the 2.284 has to increase. So when we take the 2.284, we will need to take that decimal point and move it 2 spots to the right. And that's going to leave us with 228.4 times 10 to the 6th power. And then for the one below, -1 to get to -3, that's also going to be decreasing. We also need to increase the 7.2. And so then that means that we'll take the 7.2, we'll have to move it 2 spots to the right, 1, 2. There's no number there, so we have to put in a 0. And that means that our answer for the second problem is going to be 720 times 10 to the -3 power. All right. Now, what we're going to do is we're going to be able to add and subtract the numbers in scientific notation. So with this, there is a big tip that I forgot to include here. And what we want to do, maybe you should write this right above this box here. Always, how do I want to say this? Always make the exponents match the largest exponent. Always match exponents and if you're wondering why is that the case, why does that matter? Well, let's go back to one of the problems we already solved. Let's take actually both of these, to be honest. If you look at our answers, 228.4 and 720, both of those are going to be numbers that are not in scientific notation. And you might be wondering, well, what's the big deal? Why does that matter? Well, if we were to add or subtract 228.4 with 5.9, the answer is definitely not going to be between 1 and 10. We're going to have to adjust that ourselves. That'll be extra work. Same with the bottom one here, 720 added or subtracted with 7.23 also is going to give us an answer that is between 1 and, or not between 1 and 10. It's not in scientific notation. Meanwhile, if we go back to this one here, if we take 0.09328 with 1.09, those two numbers have a much better chance of staying between 1 and 10. In fact, if we add them together, it definitely will. If we subtract them, it looks like we're going to just ever so slightly be less than 1, or excuse me, or it could be with just slightly bigger than -1, so it might not quite work for scientific notation, but it's a better idea than trying to switch this one because then what would have happened is that the numbers would not have fallen between 1 and 10 when you add and subtract. And the same is going to be true. Oh, I'm sorry, not the same. This one was different. We reduced that one, so that was a little bit different too. You can see 42.5 added or subtracted with 7.1 definitely will not get us between 1 and 10. So down here then, when we want to solve this, so as I was just saying, let's make sure that we get the same exponent that is matching the largest exponent. So that means rather than switching the first number, not switching that one, we want to be switching the second number. And so that's why I already crossed off the 3, and we're going to turn that into a 5. Then what we know, if I just write out, we've got 8.53 plus 10 to the 5th plus, and then we are going to have to change this number, so we might want make sure we give ourselves some space here. So we want, and I'm not even giving myself proper space. I'm going to leave a little bit there. I put a plus sign at the beginning there that I shouldn't have had. That should be at times. There we go. So, like I was just saying then, this here increased. We need 5.1 to decrease. 1, 2 spaces because the exponent went from 3 to 5. So it changed by 2. And now what we are going to do is we are going to add together 8.53 times 10 to the 5th plus 0.051 times 10 to the 5th. And when we add those together, we are going to get, let's see, 8 and 0 is 8. You can certainly use a calculator here. I forgot to grab mine before I started. So you might want to fact check me and make sure that's actually correct. But when we add these two numbers together, we get 8.581. And notice how this part of scientific notation is between 1 and 10, which means there is no extra work needed to correct our answer. So we are all done. 8.581. All right. So I just need to double check how many. Okay, I got one more to demonstrate, then I'll have you do the last two. Once again, be careful with the negatives because the larger of the two numbers is actually the one that is closer to 0, not the one that's closer to negative infinity. So in this case, what we want to do is we want to be changing the second one again, and we're going to change -4 to become -2. We're going to have 8.421 times 10 to the -2nd minus, let's leave ourselves some space again. This number increased, so that number is going to decrease, so let's leave some space in front. 7.12 times 10 to the -2, excuse me. And what's going to happen then is that our decimal point has to move 2 spaces again. 1, 2. Again, we're making the number smaller because the exponent became bigger. And so now what we have to do is 8.421 times 10 to the -2 power minus 0.0712 times 10 to the -2 power. Ooh, this is going to be a challenge for me to do in my head, isn't it? Oh, you know what? There's no shame in grabbing a calculator. So that's exactly what I'm going to do. 8.421 minus 0.0712, and that ends up being 8.3498. And once again, this part of our answer is between 1 and 10. That is good. That means there is no additional work necessary. So that is our answer. I should have said this earlier, but in case you're wondering, what happens if your answer is not does not have an a value that is between 1 and 10, like there? Well, that's exactly like what we did at the beginning. Rewrite the first number so it has the same exponent as the second number. All we did was that we just learned how to increase and decrease with changing these numbers. So it's going to be just like this, except obviously this one, 42.5, is not between 1 and 10. But we could still do that in reverse. We could take this answer, we turn it back to 4.25 times 10 to the fourth. That's something that you're definitely capable of doing then, based off of what I've shown you here. All right. So go ahead then. These are the last two. I want you to try them out on your own. Pause the video. When you are done, I will come back and I will show you how to solve it. All right. Okay. So for the first one, remember we need to change the exponents so that they are the larger of the two. So -4 is the larger number compared to -5. So if we cross that one off, change to -4, that had to increase, which means that 5.9 has to decrease. So let's write down our numbers now. 5.9 times 10, we're changing it to the -4th power. And here, because it changed by 1, the decimal point had to move one place. So now we have 0.59 times 10 to the -4th. And we've got 2.11 times 10 to the -4th. And when we add these together, what we are going to get is, let's see, I'm going to try to do it in my head. Oh, this is not going to turn out well. 2.70? This is a case where you don't need to include that 0. I'll leave it, but if you want to just leave your answer as 2.7, that's okay. 2.70 times 10 to the -4th. I'm going to double check with my calculator just because being sick, I can't fully trust myself right now. All right, it is correct. Okay. All right, then the last one. This time, once again, we want, oh, that's a bad green. What we want to do is we want to be changing it to the larger of the two numbers. So 8 should become 10. We're going to rewrite what we have. Let's leave some space for that 5.78. We need to move the decimal point 2 places because 8 became 10. It increased, and so we need to decrease 5.78. There's where our new decimal point belongs. We have to add in a 0. So now what we are solving is 6.2 times 10 to the 10th power minus 0.0578 times 10 to the 10th power. This one I will definitely use a calculator. I am not going to attempt to do this in my head. And so when we simplify, we get 6.1422 times 10 to the 10th power. All right, thanks for listening to this video, everybody. What you'll do now, you'll work on the in-class assignment that I have given you, activity. I guess I haven't decided yet, but anyway, I'm hoping that I will be back in school then on Wednesday. I look forward to seeing all of you again. Have a good day. Bye.